Hi everyone, my name is Chelsea Howe and my project was on using GIS to understand if whales avoid the San Francisco Bay on days where vessel traffic is higher by comparing the relationship between in situ whale count and marine traffic density in San Francisco for 14 different days in 2019. For some background on the topic, there have been reports of ship strike, and it is a known concern for whale conservation. Various agencies have recognized the evidence that that whales get hit with ships occasionally, and there's also a lack of a reporting system for when ships do hit whales, so we don't actually know how often this happens, but through necropsies, they are able to tell when whales have a lot of damage and bruises, and they're able to point the cause of death at a ship strike. So in this past month, in April, there were actually 4 whales that were found dead in San Francisco Bay, all within a week of each other. 1 was confirmed a ship strike, 1 was likely a ship strike, and 2 are still being investigated. There have also been recent mortality events, such as one in 2000 or between 2007 and 2019, where there are higher than average amounts of whales that are being washed up, and so whale conservation is definitely something that researchers are paying a little bit more attention to right now, and it's an important topic to follow to be sure that we're taking care of these animals in the way that they need to be taken care of, and that we're respecting their habitats. So this study, it looks at AIS data, which is the vessel traffic data, along with whale data based on whale watching tour observations from Allison Payne, who's a researcher with the Marine Mammal Center, to see if whales seem to avoid the San Francisco Bay. So I used whale sightings in San Francisco, clipped the data from 8 a.m. to 5 p.m. and sorry, my video is in the way, but the AIS traffic came from NOAA, the field observations from Allison Payne, and then there were 2 scripts available online also to work with the AIS data to convert the CSV files into points and vessel tracks. So methods, the study, the map making part of it, and analysis was broken into 3 different pieces, working with the whale data and the area polygon, working with the vessel data, and then running the analysis on that data together. And the goal was using only dates that have full day of whale watching trips, which would mean a morning trip, a late morning trip, and an afternoon trip. Those would be considered full days that I could use the full day of vessel traffic from 8 a.m. to 5, how many whales were seen, how much vessel traffic was out there. So for the whale and the area data, first so that I didn't have to digitize all inside of the San Francisco Bay, I used a shapefile that I found online from the Open Space District, and for that I just had that in my file to use, and then I looked through the field observations from whalegirl.org to find different days where there's a full day of data and where she would mention how many whales she saw, at what time, and where she saw them. And the locations were not extremely accurate when I went to log them in ArcGIS, because the observation would be recorded as not a coordinate, but it would be recorded as a gray whale was seen east of Angel Island, or 3 humpbacks were spotted just outside of the shipping lane. And so it was kind of more of a generalized location. And then the 4th picture, which you can't see, I did a buffer around the vessel, around the whales, the whale dots, and a buffer of 50 nautical miles, because whales can travel roughly 100 miles in a day. So assuming that they could be coming from within 50 miles that day, that would be like their area of decision making on, okay, does the whale see the vessel traffic? It's heavier and it wants to avoid it or not. And then 50 instead of 100 because it wasn't the full 24 hours. It was just 8 a.m. to 5 p.m. For the vessel traffic, so I now had 14 days of whale data, so I needed 14 days of vessel traffic. The vessel traffic comes in CSV files, so I went and found the CSV files of each of the individual dates that Allison Payne had logged in her field journal, and so I created a model since I had to go through a lot of steps for each of the files, or all the same steps for each of the files. So the model pretty much just explains that, or it converts the CSV file to points, and then it chops or it cuts out all the points that were not between 8 a.m. and 5 p.m. and then creates a feature class out of that, and then it uses one of the scripts from NOAA that converts the points to track lines, and then the last picture, which you can't see, it actually clips it to the polygon from the previous slide. And then lastly, there was the data analysis. So I ran a linear model on the results using the scatter plot chart in ArcGIS. And then since the whale data all combine, so just like one map having 14 days of vessel tracks and 14 days of whale sightings doesn't necessarily make sense unless you're looking at like spatially, do the whales avoid the vessel tracks? But that's not what I was looking at. I was looking at like each day, how much vessel traffic was there and how many whales were there. So I created a time series going through each day. So then I had to kind of add all of the time properties, and then finally I did kind of all of the symbology. So for the results, the results for the question, do whales seem to avoid San Francisco Bay on days where there is more vessel traffic? So this was kind of the heart of the study, which was the regression model. Even though the regression is kind of like not a map, I had to use ArcGIS to summarize the vessel within the area, which I couldn't have done without using ArcGIS. So the results showed that the relationship between AIS traffic and whale count was 0.013, and that indicates that 10% of the whale behavior can be explained by vessel traffic. And it was a negative regression, so it does indicate that as traffic increases, whale sightings do decrease, but it was very weak, so it weakly indicated that. The low R-squared doesn't support a strong connection, but it also doesn't completely rule out the potential for a relationship either. So the low R-squared may also indicate that whale behavior, similar to human behavior, is hard to explain because there are many factors that influence it. For instance, seasonal variation, where they need to be in their migration pattern, food availability, social structure. And it's possible that even the boats kind of churn up food for the whales, or not for them, but the whales take advantage of. So this was the final output. On the left is the linear regression, the very weak one. And on the right is everything like piled on top of each other. And you can't see the legend, but it shows that like the I'll show you in the later slides actually. So here's the time series so that you can actually see per day. So I was going to explain the legend. The green is for the least amount of vessel traffic by length, and these are like kind of grouped into classes, and then the red is the heaviest or the most summarized length of vessels in the bay or in the polygon that day. And then the black dots are the whales. So it's the high traffic. Now you can see the whales are outer bay now, and this is when the humpback whale started coming in. Okay, so that was showing you by day, but it is a little bit difficult to see the patterns when you're jumping because each day kind of has a different amount of vessel traffic. There's a lot of variability in that too. So I just organized the different maps by the class of vessel traffic length that they fall within, and then looked at kind of the trends in what the whales were doing when the traffic was like that. So this slide shows when it had the lowest amount of vessel traffic, and these dates do not support the theory because these dates had actually the lowest and second to lowest amount of whales that are spotted on any given day for these dates, and this is when the vessel traffic is the least. So this is where there is low vessel traffic, and 2 of these dates support because 6 and 14 is the highest amount of whales that were ever seen in this collection, and then 6 was the third highest number of whales that were seen, and then this was like a relatively lower amount of vessel traffic, so those do support it. The third one doesn't, although this is skewed because of the introduction of humpback whales in the summertime, so that you can see that 14 one was in July, and so that's because yeah, they start to come kind of more in the summer. And then so this is where there was high, and here we had one day with 3 whales and one day with 7 whales, and so this both supports it and rejects it. So there is high vessel traffic. There was the second highest number of whales spotted, which was 7, which doesn't support it. But then there was another day which there was 3. So this one's hard to make a conclusion with. This one, so 2 of these dates pretty strongly support the theory because there were only 2 and 3 whales seen on these days, but then there was a third day where there were 6 whales that were seen, and that's the bottom right, and you can see that's in September, so that was also influenced by the humpback whales. This had the highest, and all 3 of the days with the highest vessel traffic supported the theory because there were only 3 whales, which was the second lowest number of whales seen, and these probably influence the linear model, the linear regression. So for the conclusion and the limitations, so the study was a first look at how these relationships can be compared. There was no stronger consistent trend in the data to indicate that there may be a pattern, and more research is needed. This was my first time working with both AIS and whale data, so there were a lot of hurdles to get around, and because I had to kind of work through a lot of this for the first time, I didn't really have time to like just go back to the beginning, but I would like to have the chance to do that, and there were a lot of things that I would do differently next time. So the first limitation was using whale data that ranged across multiple species migration periods. The numbers were skewed by the introduction of a new species into San Francisco Bay. So in a future study, it'd probably be good to use like a shorter time period where only one species was logged, and kind of like more consistently every day, which that would also have its own limitation of like these whales are just hanging out here for the month regardless of what the ships are doing. But maybe a few months, one species. The second limitation was using length instead of density of points to summarize the vessel traffic. So when converting the points to lines, the script asks you to specify what the longest gap between AIS signals is that you will accept in order to snap the points. So if the AIS signals between points, even if it was the same boat, but the AIS signal like dropped out, or if the boat stopped for more than X time, then don't snap it. And I chose 60 minutes, and that was really arbitrary. But if I would have just instead used like a density or a hotspot analysis or something for the points of the vessel data, that would have maybe been less error prone and wouldn't have gaps in the lines. And that's about it. So thank you so much, and I hope to see a lot of you in other classes going forward. I hope you enjoyed the information, and see you around. Bye.